Hey guys, how's it going? So in the next couple of minutes, I want to quickly demonstrate you how IOTA as a protocol and Azure IoT Edge as a platform might work together. And before we dive into the demo, let me quickly explain like what the technologies are and what the benefits actually is when you connect both of them. So IOTA is coming from the cryptocurrency world, and people often compare it to the blockchain, but actually IOTA is quite different. So it's based on a directed acyclic graph, DAG, and because of this unique approach, IOTA has no miners. And for this reason, basically, IOTA has a very high transaction throughput, and there are also no fees, since every participant of the network have to do their own proof of work. On the right side, we have Azure IoT Edge, which is a platform provided by Microsoft, and it basically enables customers to deploy their cloud work to the device. It also maintains security standards and ensures that the module is always running. And IoT Edge, it's actually open source and it's supported by multiple platforms like Windows 10, IoT Core, Ubuntu, or CentOS, and even different architectures like AMD 64 or ARM 32-bit. All right, so as I already told you in this demo, I want to show you how a typical use case could work when you use IOTA as a protocol and IoT Edge as a platform. And when we do this, we basically don't have to deal with the deployments, since this is being done by the IoT Edge and runtime. And by the way, you're deploying Docker container, and that's why it's supported by multiple platforms. Another one is offline support. This is also handled by the IoT Edge runtime. So the developer doesn't have to care anymore whether the device is offline or online. This will be handled by the IoT Edge runtime as well. What you do is when you work with IoT Edge devices, you basically are handling device twins. So when a device twin receives an update, it basically informs the runtime. And that's why it's working asynchronously as well. We can also take advantage of artificial intelligence capabilities like stream analytics. That's the one I'm using in this demo, or even machine learning, like for instance, predicting like the weather forecast. IOTA is made for the IoT industry, and it supports device-device transaction, since the big vision here is the machine economy in the future. And last but not least, it's an open distributed ledger for sending and receiving transactions. So when it comes to payment and stuff like this, we definitely need an open way so that everyone can actually see what's going on here. All right, let's quickly have a look on the architecture, and don't worry, guys, we won't go into too much detail into this. I just want to let you know that we basically have two applications. The first one is on the left side. That's a Raspberry Pi. This is the seller who's actually selling. In our case, it's going to be temperature and humidity data. And here we have the web app. In this case, it's the buyer. So what is going on here is that the web app is actually asking the Raspberry Pi for an IOTA address, and the Raspberry Pi is answering with an IOTA address and the amount the web app has to pay. And after the payment, the transaction starts by using masked authentication messaging. And this is coming from the IOTA world, and it's perfectly suitable for streaming data. All right, guys, that's it. Let's go to the demo. All right, guys, welcome back to the demo. So what you see on the screen is basically the two different applications. The top here is the web application, which basically sends requests to the device and also receives data from the MAM channel. And on the bottom, you basically see a Linux shell, which is connected to the IoT Edge app. And I already installed the IoT Edge runtime. And let me quickly show you actually what kind of Docker images are running on these machines. So we have the Azure IoT Edge agent, and we have the Azure IoT Edge hub. And those are components which are actually provided by the Azure IoT Edge runtime. But we also have the IOTA module. This is the one, which handles all the logic needed for this demo, like creating an IOTA address or sending data to the MAM channel. We also take advantage of Azure Stream Analytics. So in this case, we will be using Stream Analytics, which will reset our device when it gets too hot. So when a device reaches a defined threshold, then actually the Azure Stream Analytics kicks in, and basically resets the whole device. This is just to simulate like maybe an artificial intelligent case. Okay, let's quickly restart the module and IoT Edge restart IOTA module. And let's also make sure that we actually see something on the screen. So there's a command provided by the IoT Edge runtime, which actually connects our shell for getting the console logs from our node application. So this one is called logs, and the module is called IOTA module. All right, there we go. Okay, on the top, you basically see the web application. And this is the one which actually talks to our IoT Edge runtime. So what we simulate in this case is that our Edge runtime provides us temperature and humidity. So let's pick a sensor. In my case, I'm coming from Germany, so I'm curious what's going on in Germany. And now you see that the request was actually sent. So I have to pay 1 IOTA. And by the way, you see on the top of the screen how much wallets of IOTA are still in my wallet. You have the location of the sensor and you have the estimated runtime. And now I can click on accept. So what I do is I'm attaching this transaction to the Tangle, and there's a link actually. So if you've never seen this is how a typical link looks like in the portal. You have the trunk and the branch, which basically refers to the transaction in the Tangle. You remember you have to basically confirm two previous transaction in a Tangle. That's how the architecture works. All right, let's go back. As you can see on the screen, we are already sending data, and you can see that the temperature actually goes up, 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 and it reaches more than 73 degrees, and that's where Stream Analytics actually kicks in. And that's why it's saying basically that the sensor gets too hot. And you can also see this on the screen now on the front end, that the temperature gets back to the 40s, and so the simulation can continue. All right, guys, I will provide you all the links to my GitHub repositories, and let me know if you have any questions. Thanks for watching.